Okay, so this is a lesson on electric circuits. So, first thing I'm going to do is draw an electric circuit. So, for some of you, this is going to be a review of things. For most of you, it should be a review, even though if you don't really remember much from a long time ago, from grade 9. So there'll be some review, and then there'll also be some new stuff. So there's an electric circuit. This is a battery, or actually a cell. This is a resistor. And in order for this circuit to be operational, in order for it to work, we need three things. We need an electric source. We need a continuous path of conductors. And we need a device. So all electric circuits need these three things. So this would be like a battery. This would be like wires, and this would be like, could be a light bulb. Say could be light bulb, a motor, an LED, a speaker, whatever. Conductors. They allow free movement of charges. And usually when we talk about circuits, we're usually talking about electrons. But it doesn't have to be. Like if you can have a circuit that goes through, say, an acidic solution, and that'll work as a circuit, and it's not moving electrons, it's moving like ions, but because ions are a type of charge. And just the opposite of a conductor is an insulator, and these do not allow charges to move. Okay, so that's the basic thing of a circuit. The first thing I want to talk about a little bit is electric source. So when we talk about electric sources, we have batteries. It's this idea of a battery, say, and voltage. Voltage is kind of a hard thing to know exactly what it is. Like people know that voltage is the thing in the batteries, and like you have a 1.5 volt battery, or you have a 3 volt battery, or whatever, or 12 volt battery in a car. And that's what gives something some power. But when we try to say exactly what is it, it's a little bit more complicated. Voltage is actually what we say electric potential energy per unit charge, which is kind of like, yeah, it's kind of a handful. The better way to think of it, or I think a more easy way to understand it, is voltage is electric pressure. And in fact, for a circuit to work, not only do we need electric pressure, but we need a pressure difference. So if we have like a cell here, I'm going to redraw my circuit. We need it to have a pressure difference. So like this could be, say, 6 volts right around here, and then down here it's 0 volts. And it's this idea that charges, or current, I guess we could say current, for now we'll just go current, flows from high pressure to low pressure. And it's not quite like that, but we'll just say charges. Current is the flow of electricity. So in this diagram here, what we kind of say is there's charges flowing this way through the circuit from high pressure to low pressure. Another example of this high pressure to low pressure thing is like if you can imagine you were holding a piece of paper in front of you and you blow on it, the piece of paper moves away from you. So like let's say you have a oops. Oh, person. They blow on a piece of paper and it'll move away. And this would be like high pressure and low pressure on the, oh, you can put the H over. High pressure on this side of the paper and low pressure on that side. And that's what makes the paper move. On the other hand, if you had that, but at the same time, you had another person on this side of the paper also blowing, and let's suppose they're blowing with the same amount of pressure, that paper wouldn't move at all. It's like the idea of balanced forces. So that's why you need a pressure difference. So if you had 6 volts here and then you had another 6 volts here, equal pressure, no current would flow. So you need a pressure difference. So that's the idea of the things you need to make a circuit work. So you need the voltage source. You need some sort of device, say a resistor or a light bulb, and you need a continuous loop of conductors. Okay, so the next thing to talk about is, we'll talk a little bit more about current. Let's use the yellow, go back to yellow, current. So I said current is the flow of electricity. But this is not speed. It's not the speed that things move. It's the amount of charges that move. Once again, we could kind of think of another analogy. Like, let's suppose you had a pipe of water. Just say you have a pipe and there's a bunch of water flowing through it. The water could be moving at, say, 1 meter per second. And you have a whole bunch of water flowing through the end of the pipe that looks like this. On the other hand, if you had a pipe that was this big, with just a little bit of water, but the water itself, the particles itself, could also be moving at 1 meter per second. This has a higher flow rate. More water per second. Lower flow rate. Less water per second. And that's the same idea with current. Current isn't, we're not talking about water, we're actually talking about charge. So for current, it's the amount of charge flowing per second. Okay. Second is a time. So the question is, what is charge? So charge, it's measured in coulombs. That's what it's called. So that's, I think. So there's a guy named Coulombs a long time ago. Actually, it's not coulombs. Coulombs. And he kind of came up with this idea. The unit for a coulomb is a C. And we could say that the base, the smallest amount of charge that we can get, is the charge of an electron. Oops. So electrons have a charge of 1.6 times 10 to the negative 19 coulombs. So that's the smallest amount of charge you can possibly get. You cannot get 1.2 times 10 to the negative 19 coulombs. Impossible. You cannot. Electrons are elementary particles. They don't, as far as we know, they don't split up into anything smaller than electron. You can, like a proton can split into quarks, or atoms can split into protons and neutrons, but electrons themselves cannot, as far as we know, they do not split into anything smaller. So the charge of one electron is 1.6 times 10 to the negative 19 coulombs. And every bit of charge bigger than that is a multiple of electrons. So if you had 2 electrons, you would have 3.2 times 10 to the negative 19 coulombs. If you had, and it just goes up by that. So you could actually say the symbol for charge is a Q. And if you want to know how much charge is somewhere, Q is some number times E. So charge, number of electrons, and charge of one electron. Okay, so that's the idea of charge. So you double the number of electrons, you're going to double the charge. What should we do next here? So we can even put that into a formula. Or actually, no. Let's go back to current then. So once again, current is the amount of charge flowing per second. So current is the amount of charge. Oops. So let's go back to current. Current is charge per time. And we can use symbols for that. So the symbol for current is I, capital I, charge is Q, and time is T. The units is an ampere, and that's a capital A. So 1 A equals 1 coulomb per 1 second. All right, so let's try a few calculations with current then. So what is the current if 6 microcoulombs of charge move through a wire every 10 seconds? So current is C divided by T. So this C, micro is 10 to the negative 6. So just as a reminder, millicoulomb would be 10 to the negative 3 coulomb. Microcoulomb would be 10 to the negative 6 coulombs. Okay, so we have 6 times 10 to the negative 6 coulombs divided by 10 seconds. So I equals 6 times 10 to the negative 7 amperes. So that's an example question. Let's do some more practice questions with this kind of stuff. How about how many electrons are there in 2.5 coulombs of charge? So once again, we have charge is equal to some number times the charge of an electron. So we know, in this case, we know this is Q, and we know this, so we're looking for N. So N is equal to Q divided by E. So in this case, we have 2.5 coulombs divided by 1.6 times 10 to the negative 19 coulombs per electron. So let's do some calculation there. I'm going to divide those two. You should get a really big number, right? If the charge of an electron is really, really small, then you need a heck of a lot of them to get up to 2.5 coulombs. So I get 1.56 times 10 to the negative 19, or 10 to the 19. That's how many electrons I need. How many electrons are in 5 microcoulombs of charge? Let's try that. How many electrons in 5 microcoulombs of charge. So similar question, N equals Q over E. So once again, micro is 10 to the negative 6, so 5 times 10 to the negative 6 coulombs, divided by 1.6 times 10 to the negative 19 coulombs per electron. So 5 e negative 6, 1.6 e negative 19. I get 3.13 times 10 to the 13 electrons. And now let's come back and do one more practice question combining these two ideas. So current is charge divided by time, and charge is number of electrons. So the last question we'll try is, what is the current if 6 microcoulombs of charge move through a wire every 10. Actually, I'm going to change it. What is the current if 3 times 10 to the 15 electrons move through a wire every 10 seconds? So we have I equals C over T. So first of all, we have to get the C. So C is equal to N times E. So that's 3 times 10 to the 15 electrons times 1.6 times 10 to the negative 19 coulombs. So our charge in this question is 4.8 times 10 to the negative 4 coulombs. So now we can get the current. Current is 4.8 times 10 to the negative 4 coulombs in 10 seconds. The current is 4.8 times 10, oops, that was supposed to be a 4, times 10 to the negative 5 amps. There you go. That's the basic structure of a circuit. We have conductors, we have electric pressure, and we have charges and current.